So now the first popular divide and conquer algorithm, sorting algorithm is the merge sort algorithm. So assuming that all of you know this algorithm, I'll not explain this algorithm in detail. So I'll just give an overview of this algorithm, then I'll show you the time complexity analysis of this algorithm. Okay. So in merge sort, what we do, let's say this is our original input or problem, you can say. So usually what we do, we divide that original list into two sublists. Okay, then we go on dividing these sublists again into two sublists. Okay, we go on dividing till we find the single element lists at the end. Okay, so let's say these are the single element lists. Okay, here let's say 2, 5. Let's say I'm putting some numbers here arbitrarily to show you how we merge them. Okay, so now we got the single element lists here. Now we have to merge. This is our dividing part. Okay, so now onwards it will merging. So when we merge these lists, what we do, we compare the elements. Okay, if this element is less than this one, then we write them in this order. Okay, so let's say here the 7 is greater than this 4. So what we do, we write them in sorted order like this. Okay, so for this one we also merge them into the sorted order, and this one also we merge them into sorted order. Okay, then we again merge these two lists and these two lists into sorted lists. Okay, like here the elements are 2, 5, and here the elements are 4, 7. So we compare this 2 and this 4. 2 is smaller, so we pick 2 first. Then what we do, we compare this 5 and 4. 4 is smaller, that comes then 5 comes here, then 7 comes here. Okay, so here also we get this list, then at last we merge these two lists. Okay, so this 1 comes first, then 2, then 3, then 4, then 5, then 7, then 8. So here we get the result for the original list. Okay, so basically in merge sort we divide all our problems into two sub problems. Okay, so this is why this is called two-way merge sort. Okay, so now we should analyze the time complexity of this algorithm. Okay, because I'm not explaining in detail this algorithm, because I'm assuming all of you know this algorithm. Okay, so see, this merging procedure is taking always big O of n time, because see, if we want to compare this array, all the numbers from this array and all the numbers from this array, so it would take 1, then 2, 3 and 4 times. Okay, that means how many elements we have in our list, that much time it takes. Okay, but the whole input is of length n, let's say. Okay, that always depends on the sub problems we are dividing into. Okay, so we are dividing into 2 sub problems of size n over 2. Okay, so that's why this depends on these 2 sub problems of size n over 2 plus the merging time. The merging time is always big of n. Okay, so now this is called the recurrence relation for the merge sort. Okay, so now using this recurrence relation we can find the time complexity of this merge sort. So how we can find? Let's say this is 2t n over 2 plus big of n. So if I tell this n over 2, this sublist again I am dividing into n over 4. So that is going to again 2 times t of n over 4 plus the time to merge this list will take this much time. Okay, this is there. Okay, so now multiplying this outer 2 with the inside factors, so what we'll get, this is 2 times 2 means 2 power 2 t of n over 4 plus 2 times this big of n over 2 plus big of n. Okay, so now let's write this big of n in forms of some constant times n. Okay, if you wonder how I'm writing that, you have to watch my previous videos. Okay, so I'm writing this is n over 4 plus I'm writing this big O of n over 2 in form of some constant into n over 2. Okay, let's say I'm writing this is c times n over 2, this is c times n. So this 2, yeah, so now this is 2 power 2 and this is n over 2 power 2. Okay, plus this n we are adding that much time. How many power we are taking here? We are adding this n that much time. Okay, so in the last step when we find this t of n over n, that means we get the problem of length 1. Okay, so there n over n means this n is equals to 2 power something. Okay, so what is that power? If n equals to 2 power x, then we can simplify x equals to log of n base 2. Okay, so I can write this power as log of n base 2. Okay, so now here we are adding this cn how many times? This many times. Okay, so this plus cn plus this cn, this is going to be log n base 2 times. Okay, so now this 2 power log n base 2, it becomes n. Okay, and this is going to be 1 because this is of 1 length, so this is going to take only constant time. Okay, big of 1. So because we are adding cn how much time, log n base 2 times, so we can write this one like cn times log n base 2. Okay, so here which one is greater? This n, this is constant time, so we can neglect this one. This is n and this is n log n, so which one is greater? This one is greater, so we have to take the time complexity of merge sort is bigger of n log n base 2. Okay, so this is how we get the time complexity of merge sort. Later on I'll tell you how to solve the recurrence relations. This is one way to solve the recurrence relation. There are also more ways to solve this, so I'll discuss those in my next videos.